So today we're going over two-dimensional arrays. And two-dimensional arrays, if a standard single-dimensional array is like a list, a two-dimensional array is like a table. Okay, it's that's how I equate these, and those are the analogies I use. So again, a single-dimensional array, which is what we did last class, is a list. Two-dimensional array is like a table. Now, if you were in my programming one class last semester, we didn't go over two-dimensional arrays. So technically this might be the first time you've seen it instead of a review. However, we won't use two-dimensional arrays a lot in this course anyway. However, I do want to introduce you all to it so that you have some idea of what it is. And in the future, if you're writing a program, you could use it if need be. So again, a two-dimensional array is like a table. So let's initialize a single dimensional array first. I'm going to do strings. String brace names equals new string. All right, and I'm going to make this of size 5. Cool. And as we know from last class, this creates an array of size 5. 1, 2, 3, 4, 5, right? Indices from 0, 1, 2, 3 to 4. Those are 5 indices, correct? Yep. All right, so each one of these, when we initialize this, will be empty strings until we add something to it. Just FYI, it's just an empty array. Just like if we made this an array of integers, it would just be zeros all across the board by default. So that's a single dimensional array. Okay. Let's create a two-dimensional array. So if that's how we do a single dimensional array, we'll do another one of strings that's a two-dimensional array. So string brace, that's single dimensional. To do a two-dimensional array, another set of braces. Brace. Let's say students equals new string brace. The first one is the number of rows. The second brace is the number of columns per row. Okay. So I'm gonna do 5 by 5. That creates a perfect block. 1, 2, 3, 4. Right? 5 columns. Each one, 5 rows, each one with 5 columns. Right? And just like before, our indices go from 0, 1, 2, 3, 4 for the rows. 0, 1, 2, 3, 4 for the columns as well. Okay. And technically in memory, now again, the analogy I use is a table. But technically in memory, this is an array of arrays. So we create an original array that points to additional arrays. Just to FYI, in memory, that's how it's organized. It's not organized in a table format because memory is all sequential. So what it is it's an array that points to other arrays in memories. So technically in memory, it actually looks like this. 0, 1, 2, 3, 4. Each index points to another array. So technically, this is how it looks in memory. All right. But for our purposes, don't worry about how it's organized in memory. Just think of it as a table. All right. So if this confuses you over here, if all that confuses you, just ignore what I said. Just ignore all that even happened. But I do want to let you know that in memory, that's how it's organized. It's not organized in a table. But for our purposes as programmers, we can think about it as a table. All right. So if I do this, a 6 by 5, all I did was add another row down here. right? And now we have index 5. All right. Any questions so far?
Yeah, I got so is it gonna be string and not int? Or does it matter?
It just depends on what type of data you want to hold. So right now I'm
Okay.
holding strings, which are, words, letters, can be
Yeah.
numbers. If you are holding integers, whole numbers basically, by all means, you can make an integer multi-dimensional array.
Gotcha.
You can make a double multi-dimensional array. And in this class, we're going to use something called objects. So you can also hold objects in your arrays as well. So your arrays are powerful structures because they can hold many different types of data. However, do be mindful of when you create your array, you cannot change the type of data you store in it. So if you create an integer array, it only can hold integers. If you create a double array, it can only hold doubles. If you create a string array, it can only hold strings. It cannot be changed, nor can the size of your array be changed without initializing a new array. So you'd have to do that statement again and then change the size if you want to change the size. However, once you do that, all your data is lost from the old array. Any other questions? All right. So if I want to set the name of this index right here, what are the coordinates of that index? So this one.
It would be 2, 2, correct?
Correct. Two. So let's say students, it's lowercase s, students so that index is 2. So if we want to access that index, we go students, which is the name of our array, at index 2, right? That's the row 2, row 2. This is the column. Let's say it equals, I don't know, Jane Doe. All right. So now this value, Jane Doe, will now be in row 2, or I mean index 2. Okay. What if we want to access this index? What is the coordinates?
4, 4.
4. All right. Row 4, column 4. What about this one?
5, 5, 0.
5, 0. Correct. It always goes row first, then column. That's what I was trying to drive home. We're always going to do row first and then column. Okay. Any questions about multidimensional arrays? All right, let's do a programming example. So I'm going to use our program that we worked on last time. Okay. So we have review 4. I'm just going to right click this, copy. I'm going to call it review 5. There we go. And it called it review 4. All right, so perfect. Okay. And the reason I'm using this because I can kind of do the same thing that we did last time. I can use the code that we have and just extend it. So again, we have LeBron and we have KD. All right. So instead of LeBron and KD, let's do the entire Lakers and the entire Nets. All right. Every player on the team. And then based on how many points were scored per game, determine who wins and then the subsequent records of those two teams. So we're going to assume that they played each other 82 times the entire season. All right. Every game was against one another. So let's delete this code for right now. We can keep number of games. Okay. There's still 82 games. So let's create our first array. Integers again, we're holding our scoring number. So int brace Lakers equals new int. All right. Rows and columns. Typically, when you think of scoring or a box chart, scoring box, what is it? Box chart, box score. There we go. The box score, right? You think of it as players in the rows, how many they scored in the columns, okay? So how many players are in an NBA roster? Well, I know the max. I don't know how many the Lakers have right now. I know the max is 15. So that's how many rows we want. And then however many number of games. So number of games. To be more efficient, I'm going to put int max players into a variable so that I'm not explicitly typing it here. I'm putting those in variables so that I change it once, it changes it everywhere. So there are 15 rows by 82 columns. And let's see. I'm just going to put opponent, right? Because we're just looking at the Lakers. New int, max players, number of games. All right. So we have the Lakers and then all of their opponents. Okay. So let's loop through these arrays. For each player, we're going to generate a new box score, right? How many points they scored. And then we're going to go to each game as well. So for in row equals 0. Row is less than max players. Row plus plus. Instead of max players, though, right? Because we want to know how many rows there are, we can just do Lakers.length. Lakers.length gets us the number of rows. Okay. And I actually want to do this a different way. So instead of going row and then column, I'm going to go one column at a time. So one game at a time, and then go to each row of that game. So I'm going to redo this. So int column equals 0. Column is less than, and I'm going to explain what I'm doing. All right. So what did I just do here? So now I'm going to loop through all of the columns as my base. Okay. This for loop loops through all the columns. So column equals 0. Column is less than Lakers at index 0. So I'm getting that first row, right? And again, multidimensional arrays are arrays of arrays. So technically, when I get this first row, it's another array. So I can call a dot length on that, and that gets me the length of that array. Basically, how many columns there are. Then column plus plus. All right. This gets me that first array. Dot length gets me how many columns there are in that array, or basically how many columns there are in that first row. So I'm going through each column individually, starting from 0. For each column, I want to loop through all of the rows. So I start at column 0. I want to go through each row, basically each player for the game 0. Right? Because the columns are the games, the rows are the players. So I want to loop through each player for that first game. So for int, good Lord, int row equals 0. Row is less than Lakers dot length, row plus plus. And right here, I'm saying Lakers dot length. Remember, our array, our multidimensional array is an array of arrays. So when I say Lakers dot length, that gets me how many rows there are in our multidimensional array. This gives me how many columns there are in the first row. This gives me how many rows there are overall in the table. Okay. And so for each column, I want to loop through all of the rows. Okay. Basically, for each game, I'm going to loop through all of the players and generate a random box score, a random how many points they scored. So I'm going to say, let's say LeBron is index 0. So if row equals 0. And actually, we can do a switch on the row, case 0. All right. So if the row is 0, this is LeBron. So we'll say Lakers at index row, column equals, and right now that'll be 0, 0. Equals points. That's our random point generator. We said he scores between 25 and 40 points a night. Break. Let's say case 1 or player 1 is Anthony Davis. Lakers, row, column equals points. He scores between 20 and 40. Let's go with that. All right. Let's say case 2 is Russell Westbrook. All right. I'll say he scores between, let's say, 10 and 30. It's quite wild. Break. Everyone else, any given night, row, column equals points between 0 and 50. This is 0 and 20. Nah, 0 and 15. Who am I kidding? All right. So that's for the Lakers. Okay. Everybody following so far? If this is going smooth over your heads, please let me know. If it makes sense, thumbs up. If it kind of makes sense, thumbs down. All right, so again, this first for loop loops through all of the in row 0, basically the first row. The second for loop, this nested for loop, loops through all of the rows per column. All right, so when column equals 0, we're going to go through all the rows for column 0. Case 0, I'm going to say team's best player. Case 1, team's second best player. For the Lakers, that's Anthony Davis. Case 2 is team's third best player, again, for the Lakers, Russell Westbrook, supposedly. And then the default is everyone else. Okay. So here is LeBron, AD, and Westbrook. Is everybody following this code so far? And you notice, although we're looping column then row, we do put row first and then column when we access our array. So let's do the opponent, because this is their best player as well at row. And again, these are two different arrays, equals points. Let's say they score between 20 and 50. All right. Opponent, their second best player, scores between 15 and 40. Their third best player scores between 10 and 30 as well. And then everyone else, I'm going to do the same thing. Opponent, row, column, equals points, 0, 15. All right. So we basically populated both our arrays with randomly generated scoring totals. All right. With me so far, thumbs up. All right. So if I printed out these arrays, you would see just, huge point total, 82 games. That doesn't really tell us much. We can do, interesting things. We can calculate points per game. We can calculate for the whole team. We can sum up the rows. We can do all types of things with this code. So let's create a method, public static int sum. And it takes an array. Basically, what I want this to do is sum up the values in this array. Okay, that's all I wanted to do. Sum up the values in this array. So we've already done it up here. So I'm really just going to copy this, paste, make this an integer instead. And then return sum. All right. So since I have that now, I have this sum method. I can delete this up here. I don't like repeating code. I'll just call that method from this method, just to make this one a little bit cleaner. So what I do, since both these methods right here and down here doing the same exact thing, this one is more appropriate for this logic. So what I can do is replace it up here and just call that method passing in the numbers array. Right, so that just cleans up my code. I could keep it the same. However, by doing that, let's say I change how I calculate the sum down here. I would have to change it down here and in this method. However, by calling this method instead, now I can just change it once, and it's, it also changed up here in the compute average method. I do want to change the name of this variable or change the name of this method to sum array, just to be clear, because we had a variable called sum and a method called sum. I don't like repeating names. Did that make sense to everybody?
Yes.
All right. I assume that goes for everyone. All right, sum array, and then we have compute average, all that good stuff. So let's go back up here. So now what I want to do is sum up each game, determine who wins. All right. So I'm going to create int an array Lakers record equals new int size 2, right? Wins and losses. Int opponent record equals new int size 2. Again, wins and losses. Index 0 wins. Index 1 losses. Right? Instead of creating all those different variables like last time, now we just can make arrays for it. When I did the Steelers record, remember I had all those different variables. Now I can just create an array to hold those values. So let's loop through our array, or both of our two-dimensional arrays, sum up each column, and then from there, sum up each column, and then from there, determine who won the game based on those sums. So I might have to do this a little bit differently. Int call equals 0, call is less than Lakers at index 0 dot length, column plus plus. For int row equals 0, row is less than Lakers dot length, row plus plus. And if you want to go this way, we're going for each row, we're going to go to every column. Yeah, every column. I'm sorry. For each column, we're going to go to every row in that column. If you want to do the inverse, so for each row, you want to go through each column, then you would swap these two for loops. So you would do the row first, and then the column would be nested inside. That way it goes to each column and then the next row. For our purposes, we want to go to each column and then every row in that column. Okay, that's how we want to do it. Every cell in that column. So let's sum up that row or that column, right? That'll tell us how many points were scored in that game. And my sum array method down here doesn't quite work anymore, right? Because the rows are arrays. If we look from a column perspective, it actually is several different arrays we're hitting. So you can't just call some array on the columns of a multi-dimensional array. So instead, I'm going to create another method, public static int sum columns. And I'm going to pass in the multi-dimensional array. So for int column equals 0, call is less than numbers at index 0 dot length, call plus plus. For int row equals 0, row is less than numbers dot length, row plus plus. Again, what I'm trying to do here is for each column, go to every cell in that column, every row in that column. And I'm going to sum it up. So int sum equals 0. And then we just add the row in the column or that cell to our sum. So sum, and actually, hold on. Let's do this. Int numbers, and then int column. What I was doing was summing up the entire array. I don't want to sum up the entire array. I just want to sum up one column. So instead of going through each column, what I'm going to do is I have my two-dimensional array. For the given column that's passed in, sum up that one column. So I don't need this for loop anymore. I just need the row for loop. All right. Now I can just do sum plus equal numbers at whatever row, column. That sums up one single column. Okay. So I pass in column 0, it's going to sum up all of the rows in column 0. And then we return sum. Questions, please ask questions. Do you even know where to start to ask a question? Okay. So again, two-dimensional arrays are like tables. Okay. So for a box score, right, or a scoring table, we want to sum up all of the scores in one column. So basically game one, we want to sum up all of the scores so we can determine how many points were scored by the whole team. So what I'm doing here in this method, you pass in your multidimensional array and you pass in the column number. Let's say column number is 0. All I'm doing is I create a variable for sum. It starts at 0. For each row in this column, add that cell to our sum. So sum plus equal numbers at that row at the column that was passed in. So if column is 0, this would be row 0, column 0. Add that to sum. And then row equals 1. So we'll say row 1, column 0. Then row equals 2. Row 2, column 0. Add all of those cells to our sum. Return our sum. Does that make a little bit more sense?
Yeah, so if we just wanted the rows, then we would just do sum plus equals numbers and then just the row, not call.
Yeah, if you just want the rows,
Mm-hmm.
you can pass in. So right here, it says sum array. I can do sum row. So here, all I would need to do is go through each column in that row. So for in column equals 0, column is less than row, I'm sorry, numbers at that row dot length, column plus plus, and then I'll just do row call. That way, I have the row number. So for every column in that row, right? So numbers at that row dot length, add the numbers row, which it starts at 0, if you will, and column 0, add that to sum. So this is how you would sum up the row or a given row. This is how you would sum up a column that's passed in. So summing a row, summing a column. Still iffy for some of you? I'm happy to review it as much as possible so that you all understand it. Again, we're not going to use the multidimensional arrays a lot in this class. The homework for due Sunday will require you to make a multidimensional array, and I believe you either sum the rows or sum the columns, one of the two. So you will need
That's
to know
why
how
I
to do it
asked.
for the assignment. But in this class going forward, you won't necessarily have to use multidimensional arrays, but I do want to introduce them to you. So you see now this method up here no longer works. So I have to create another method, public static int sum array. int numbers. I'm just going to sum up this array. For int I equals 0, I is less than numbers dot length, I plus plus, sum plus equal numbers at index I, return sum. We will use arrays in this class though, not necessarily multidimensional arrays, but arrays.
Can you tell me real quick, just refresh my memory, why you use the double on one of them and then the int on the other one?
So up here versus this.
Yeah.
Yeah. Okay. So for computing the average is likely to have a decimal point. All right. So that's why I use the double up here. And what it does is, so this array is all integers. So when I sum it up, there aren't going to be any decimal points. So I can just return an integer. When it returns up here, it's going to convert it to a double so that when I divide it right here, it'll be a decimal point. If I left this as an integer, it's going to chop that decimal point off, right? So whatever the division is, let's say it's 25.5. By this being an integer, it'll chop off that 0.5 and it'll just be 25. I don't want that. I want to keep the precision to that 0.5. That's why this is a double in my compute average method versus these methods where I'm just summing it up. I'm not doing any division or anything like that. All right. So we go back up here.
All those public status, all those public statics is within the first like the main one, right?
No, so the main method is up here.
Yeah, that ends where? Okay,
Right
okay,
here.
okay.
So it's important to make sure that all of your methods are independent of one another. You can't have a method inside another method. All right. But do be mindful that all of these methods are inside my class brackets. So my class starts up here, and every method I write is in between those two brackets.
Yeah, that's what I was talking about.
Yeah.
Okay.
But each method individually is independent of one another. All right, so now that we have these methods down here that it sums an array, sums a row, sums a column. Now up here, it makes our code a lot simpler. Now we can just go through each game, sum up the column, see who wins. So for int column equals 0, column is less than Lakers 0.length, column plus plus. We're going to go through each game. I'm going to change this to game equals 0. Game is less than that. So for each game, we're going to go through, sum up the column, see who wins. So int Lakers score equals sum column, pass in our Lakers multidimensional array, and the game number. That gets us our Lakers score. And opponent score equals sum column, opponent array, and the same game. Now, what's cool about this program that we're writing, yeah, I'm using this as an example. But to Brendan's point last time, these are some of the same logical statements that are used by ESPN to determine what the record is going forward. So for example, what they do is, or I don't know exactly what they do, but if I was writing the program, this is what I would do. I would take all of the historical records for the players that play on that team, determine their average and the standard deviation of how many points they score per game. Randomly generate those numbers for an 82-game season, sum them up, and see what their record is. And that's how you would determine, hey, they're likely to win this many games versus this year. And if you were a gambling person, I don't know, you could use that in your gambling logic. I'm not a gambler, but it would be an interesting tool. All right. So if Lakers score greater than opponent score. So this means the Lakers won, right? Lakers record at index 0, right? Because like I said, index 0 is the wins, plus opponent record at index 1, that's the losses, plus what? Plus. So although it's a loss, we're not subtracting, right? We're adding to the amount of losses they have. So first they start with 0-0, then they have 1 loss, then 2 losses, however many. Else, and I'm just going to assume that there are no ties. Obviously, there is a possibility that they tie. Using this, obviously, in the real game, there are no ties in the NBA. However, in this program, there is a small possibility that they can tie. I'm just going to assume that for this purpose, I don't have the logic in here to avert that. So I'm going to assume if it is a tie, it's just a loss. Lakers record at index 1, plus. Opponent record at index 0, so they won, plus. Once we're done with that, I'm just going to print it out. System.out.println Lakers plus Lakers record at index 0 plus a little dash plus Lakers record at index 1. All right, so it's going to print out 25 and whatever, or 41 and 41. System.out.println opponent plus opponent record at index 0 plus a little dash plus opponent record at index 1. And there we go. This is our full program over the course of 82 games. Each team has 15 players that can score between 0 and 40 points or 50 points. And so we're going to determine, randomly generated, what the Lakers record is and their opponent record. So I'm going to debug this so that we can go line by line. All right. Put a couple break statements in here. Hit the debugger, select main class. And you see, once it runs, it's going to stop here. All right, so I just stepped over those 2 lines. Now we have our Lakers multi-dimensional array. You see it has 15 players, and the opponent multi-dimensional array, which has 15 players as well, each one of length 82. But if you look at the array itself, it's length 15, right? Because there's 15 players. Each player plays 82 games. All right. So we go through here. If row equals 0, so the top player, we're going to say LeBron between 25 and 40 points. So if you look at the Lakers at index 0, you'll see this first one is going to make a number. He scored 33 the first game. Then we break. We also do the same thing for the opponent. So the opponent scored 39 points. All right. And we break, go back up. Now row equals 1. All right, row equals 1, column still equals 0. So we're still in the first game. So let's see how many points AD scores. Right now he's at a 0. Okay, he scored 34 points as well. Let's see how many the opponent scores. They scored 28. All right. We break. Then we go to the next one. Now row equals 2. So we're going down to Westbrook. Let's see how many points Westbrook scores. He scored 15. That sounds about right. Let's see how many the opponent scored. They scored 26. All right. Then we break. And now we're at everyone else, right? Row equals 3. There is no case for 3, so everything else goes to default. Go down here. Let's see. Row 3, they scored 10 points. The opponent at row 3 scored 12 points. And so that's going to continue all the way down for each player on the team and for every single game. So I'm just going to skip all of that because that's a lot to sit here and go through. So if I hit this little green arrow up here, it's going to jump to my next break statement, which is down here. And you'll see that this whole array now is filled in. So all of his games are filled in. This is LeBron. All of his teammates are filled in as well. All right. Using all of this information, we could, again, for each player, we could determine their points per game. So now we're going to do the record for each team. So Lakers record, opponent record. We're going to sum up the scores for each team. So you'll see Lakers record, opponent record, and it'll increase as we go through this. So the first game, the Lakers scored 144 points. Their opponent scored 194. So obviously they lost. You see the record? The Lakers are 0-1 now. And the opponent is 1-0. The next game, the Lakers scored 174. The opponent scored 147. Now they're 1-1. 150 to 148. 2-1. 142 to 154. 2-2. 3-2. 4-2. This is actually a lot more realistic than I thought it was going to be. All right. So right now they're 6-5. Their opponent is 5-6. I'm going to jump to my next break statement. It's just going to go through all of the games to determine what their record is. So they were 40-42. That's actually a lot more realistic than I thought it was going to be. So then our last two statements are system.outs. Lakers are 40-42. Opponent is 42-40. And then we're done. So that's our multidimensional arrays. Again, it's like a table. You can hold a lot of data in a table, just like any table you see out there in the real world. And there's a lot of things you can do with that table. It's just about knowing how to do it, knowing the logic of how to sum up a column or how to sum up a row. All right.